Okay, this is 13.1 part 1 of your video notes. So make sure that you have your paper in front of you for your notes. You should be looking at a paper that looks like what's on the screen. Okay, so 13.1 part 1. 13.1 is about three-dimensional figures and being able to look at a three-dimensional figure and find the surface area of that figure. Now, a 3D figure has to have 3 dimensions. And 3 dimensions. This means that it has a length, a width, and a height. Okay. A length, a width, and a height for this 3D figure. So I can take anything on my desk, like I have this water bottle, right? It has a height, it has a length this way, and then if I were to turn it this way, it has a width that way, okay? I could also I have a lot of round things on my desk. Oh, I have this tissue box. This tissue box, right, has a height here, a length here, and then if I turn it like this, it also has a width on this side, okay? So that means that there are 3 dimensions. You can measure this side right here and then up this side as well, okay? Now, a net it's very related to a 3-dimensional figure, but instead it is an unfolded 3D shape. Now, the reason why we have nets is because when we have a 3-dimensional figure, it's really hard to draw on paper as it is, right? You take something that's like actually tangible, something I can pick up and hold, and I try to draw it on a flat piece of paper, it's going to be really hard to do that. And so what we do is we unfold our 3-dimensional shape and we draw it as it's unfolded on the paper so that we can see all of the sides at once. So basically what we're going to do is we're going to take the 3D shape and make it 2-dimensional. That way it can actually fit on a piece of paper. Okay, so there are a couple different types of 3-dimensional figures. The first type is prisms. So this category of prisms, there are some very specific conditions for prisms. Now, prisms have 2 identical faces that are usually opposite each other. They can be a triangle, it can be a square, it can basically be any shape. 2 identical faces that are opposite of each other. And then those 2 faces are connected by rectangles. Okay? They are connected by rectangles. And what I mean is, we see this first one. This first one is a cube on the screen. You see the cube? So this one right here. This is a 3-dimensional figure of a cube, okay? So what we have is 2 faces that are identical, the top and the bottom, and then all around they are connected by rectangles, because we know that a square is just a type of rectangle, okay? So this is a cube, okay? We also have a rectangular prism. So this is a rectangular prism where we have 2 squares on either end. Here's the front one, and then there's one on the back here. And then they are connected around the sides by these rectangles. So this is a rectangular prism, okay? We also have a triangular prism, which looks like this, where you have a triangle and a triangle, right? Both sides have a triangle on them, and then they're connected by, if you look on the edges here, on the surrounding sides are all rectangles. So that looks like, if I were to take my pen here and let's Okay, so we have our triangles. There's one there and one on this opposite side. And then along the sides, we have one triangle here, or one rectangle, excuse me, one rectangle there, one rectangle along the back, and then another rectangle along the bottom. So that's 2 triangles and 3 rectangles. Okay, and this second shape here, excuse me, when we're looking at 3-dimensional figures, this is an example. The drawing is kind of a 3D drawing. It's not exactly a net, but this rectangular prism here in the middle, okay, that's the top. Okay, this is the bottom, and then we have the sides here. Now, you see the solid lines? That means that we can see those with our eyes. Okay, those dotted lines represent the sides that would be on the back if we were able to see through the shape. So this means that we're looking at the front, and then these lines means this stuff is behind the shape. Okay. Okay. The other type of 3-dimensional figure is a pyramid. Now, a pyramid is a little bit different than a prism because a pyramid is, it has one base. It has one base shape, and then all sides come to a vertex. A vertex is just another word for a point. Put those in parentheses. So it's one base shape, and then all the sides come to a point at the top. Okay? All the sides are triangles. Okay. So the first type we have is a square pyramid. We have a square pyramid here. This is a square pyramid where we have the bottom is a square shape, and then the sides are all triangles along the sides, coming to a point at the top, just like the pyramids of Egypt. Okay, now when I unfold this, I could see all the individual sides. Now, because the square on the bottom, it's a square, which means all the sides are the same length. Okay, on a square pyramid, all the triangles are identical to each other because the bases and the sides have to match up on the square, and the square has equal, identical length sides all around. Okay, so on a square pyramid, basically you have 2 different shapes. You have a square, and then you have 4 of the same exact size triangle. Okay. We also have a rectangular pyramid, and I do not have an example of a rectangular pyramid, but let's look at this rectangular pyramid because it's really important to note how the square pyramid has 4 identical triangles. Okay, they're identical triangles all the way around because the square has identical sides along the bottom. But a rectangular pyramid has do you see there's this triangle here, and this triangle here are going to be a little bit skinnier on the bottom because this length is shorter than the other length. So you'll have those 2 triangles which are identical to each other, but then you'll have these 2 triangles. Let's see, the one there and then one along the back that are identical to each other. And those will be a little bit wider because that baseline is wider. Okay. All right, the last type of pyramids we're going to talk about today is the triangular pyramid. This is a triangular pyramid where there's a triangle on the base, and then all the sides are triangles as well, okay? So that means when we unfold it, what we have is 1 triangle on the bottom, and then 3 triangles along the sides, okay? Together. Okay. Now, not every single triangular pyramid is going to be even on all three sides. The one I just showed you, actually, all of these triangles are the exact same size and dimensions. They're exactly the same. So when I put it together like this, it doesn't matter which triangle I am pointing to. They all have the same base and height, okay? But you can sometimes get pyramids, triangular pyramids have a really small base and a really tall point. So then you have different size triangles, okay? Okay. All right, so our last part for this video notes is let's look at these nets. These are what nets look like. Basically, we took the shape, the three-dimensional shape, and we unfolded it and drew it on the paper. There is a typo, though, because I should mistake. This should not be will this create a net. It said will this create a 3D figure, okay? Okay, will this create a 3D figure and why? Let's look at this shape, the first one. And I have my cube here. Okay, basically what this is we have this shape. Get my sticky notes here. Okay, our shape looks like this, but then we also have one that goes here too. Okay. So when we fold this up, let's fold it up and see what happens. We fold it up. Okay, this is our bottom and our sides going around. Now, if you can see here, I have my cube here. We have the top. There's an empty space, okay? There's an empty opening top. We have a side that doesn't have a side, okay? But then we have this side right here that when I fold it up, it overlaps with the bottom, okay? So in this case, this shape would not create a three-dimensional figure, okay? Now, so when we look at this shape, it should be, okay, this one right here, we can't have two on the bottom. One of those has to go on the top, because if we take this and we move it to like here, and we circle it around like this, you see how I have a top flap, and then I also have a bottom flap. So now it's all filled in, okay? So this has to go somewhere on the top, okay? Now it can go anywhere on the top, because look, see how the picture, okay? I can have one here, I can have one here, I could have this top one right here instead, I could have the bottom one down here instead. As long as you have one on the top and one on the bottom, you should be good. Okay. That first one's no. Let's look at the second one. Okay. Now, if I were to take this shape, okay, our shape here, and I'm going to put this one right here. There we go. Ish. That's the shape we have. I guess I should flip it over that way so it looks better. There we go. Okay. So this is our shape. So when we put it together, we're going to put the sides around. So now our sides are good. Do you see how I have a top flap that goes here? And then I also have this flap right here that's going to go on the bottom. Oh my goodness, this is very complicated. Okay, that is going to go along the bottom like that, and so that works. And now look, that was a different configuration. Do you see how I have this configuration too? Where I have the top and the bottom ones are right in a row like that. And this one works too, right? I just showed you before. You can take this and do that, okay? Okay, so this one is, yes. Okay. All right, so for this last one, the last one for this one, the pyramid, the prism, excuse me, this cube, okay, what we have is we have 5 across and then 1 on the bottom. So what we have is this, okay? Now, if I put this all together and I put the sides together, do you see how what I'm making is I'm making actually a pentagon. Yeah, pentagon. And then I have this like random side right here that's, oh my goodness, that's going to turn it into like, it's just a square. It doesn't work, okay? It doesn't work. So what we need to do is take that, one of these, and put it up here. Oops. Okay. So this is a no. Okay. All right, let's look at, let me find my, I had a rectangular prism, I thought. Oh, maybe I don't. Rectangular prism is the only one I do not have. That's sad. Okay. Well, a rectangular prism follows the same rules as the cube. Is that if you imagine taking those three triangles and joining them together, so say I have this, okay, this is a rectangular prism, not a triangular prism, but let's pretend that our two ends are triangles, and I have a triangle here, and I have a triangle here. When I roll these four sides up, I'm going to have one here and then one along one of these edges right here, and they're going to overlap, and I'm going to have the bottom empty. Okay. But if I have one on the top and the bottom, when I roll these sides up, see how I have a bottom flap, a top flap, and a bottom flap, and then all sides are covered. Okay, so then that would mean that the second one is no, we have to have that one on the bottom. And then that second one would be yes, because there is one on the top and one on the bottom.